Hey guys, alright, some practice problems concerning permutations. The first two that we'll do will deal with words so that we look at the different types of formulas. Alright, so this is a permutation problem, and if you notice, all my letters in the word are different. My formula in PR, that equals n factorial over r sub 1 factorial, r sub 2 factorial, and then this is a multiplication dot, and then this is whenever the elliptical all the way to r sub k factorial. And r represents the repetitions, so r represents repetition or identical items. There are no identical items in here, so I know that r is going to be 0. How many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8. So what I know is that n equals 8 and r is going to be 0. So I have 8 permutation 0. So I have 8 factorial over 0 factorial. 0 factorial equals what? 1. And 8 factorial, again, I'll briefly show it, but then we'll write it out, is that is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 1. And what that actually equals is 40,320. So there are that many different permutations of the word fraction. So let's look at another word to where we have multiple reoccurrences or identical letters. I will still use the same formula. In this problem, I'm going to have r values. So first thing I'll do is, what is n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10. And then I'm going to have multiple r values. So r sub 1, I'm going to say let r sub 1 equal a. And I have 1, 2, 3. So r sub 1 is the value of 3. And then r sub 2 will have it be z. 1, 2, 3, 4. Let's see. T, so we have r, there's only one, there are 1, 2, 3 a's. And then I can also turn around and I can simply say, okay, so r sub 3 is going to be equal to r, which is 1. And r sub 4 can be equal to m, which there's only 1, and r sub 5 can be equal to t, in which there's only 1. 1 factorial is simply 1, so I don't have to actually use these three. Okay, I don't have to actually use those three. So what I'm looking at here, n is going to be 10, and for my r values I have 2. I have 3 comma 4. So I have 10 factorial over r sub 1 factorial, it becomes 3 factorial, and r sub 2 factorial is 4 factorial. And again, I could put 1 factorial, 1 factorial, and 1 factorial in here. It's just 1. And then I will show you the canceling out. So 10 times 9 times 8 times 7 all the way down to 1. That's what 10 factorial is. and this is 3 times 2 times 1, 4 times 3 times 2 times 1. Well, I can, without having the calculator, if you write it out, it helps you be able to see it. I know these will cancel with this. And then let's see, 3 times 2 is 6, so I can cancel that out with number 6. So with my calculator, that's all I have to do is say 5 times 7 times 8 times 9 times 10. And what that gives you is 25,200 permutations. So if we look at this word, it only has 8 letters. This one has 10 letters, but there are fewer permutations in it because I can only move Z around so many spots. 4 of those, once a Z fills that spot, then that spot is no longer. So I just can't keep rotating the same letter through there. Those are 2 forms of permutation. Let's look at one other example. Okay. 14 people are competing for the top 3 spots in a graduating class, and it matters those spots because the very first one, the highest honor, is the valedictorian. The second is the salutatorian with honors, and the third is the salutatorian. So it does matter. How many possible ways can this order be established? So for my problem, what I have, and there's no repetition in here, so this goes back to the other form of the permutation formula. N factorial over n minus r factorial. And you need to establish what is n. N is my total sample space, so n will be equal to 14. And how many positions am I looking at out of those 14? I'm looking at 3, the top 3 positions. So with this, I simply plug in. I say 14 factorial over 14 minus 3 factorial. I end up with 14 factorial over 11 factorial. Again, I can cancel out. What I'll be left with is 14 times 13 times 12. Just give me 2,184 different possible permutations. These are my outcomes. Okay, so hopefully what you're able to see there is that the math behind what we're doing with the permutations isn't difficult. It's what I spoke to you about in being able to discern with permutation. Okay, order does matter, permutation position, it's like a list. Those are the things that you have to be able to discern from what the problem is asking between, is this a permutation problem or is this a combination problem? And the main thing is being able to say, okay, the position that I draw them first, second, third, however, does matter. For something as simple as you're given a word and you're asked how many different ways can the letters be rearranged, that is a permutation. But remember, it's a different formula than the one that we used here. Okay guys, watch your publisher's videos. Please critically think about these problems and reason through and think of them. Structure your work. And as always, good luck on your homework.